Hello friends, do you know what is the cross multiplication method in solving the linear equations in two variables? Let's see how to do it. So let's say that we have these two equations, a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. And these are in such a form that we are not able to apply any of those previous methods that we have learned. So this is one more method that we can use to solve the questions very easily. So how we are going to do it is we are just going to find out the numerators and denominators for these function, and then we are going to solve it. So for x, what we are going to use, we are not going to use x column. Okay, we're going to use y column and the constant column. So how we are going to use it is we're going to use b1 with c2 and b2 with c1. So it is b1 c2 minus b2 c1. So for x, so this is x, this is y, and this is constant. So we are just using this minus this. Okay. So this is for x. So that's what I've written here, right? Equals to y upon. So for y, what we're going to use is if we have these three x, y, and constant terms. For y, what we are going to use? We are going to use x with this one and this one with this one. But we are going to put minus 5 because we are changing the direction. So we should have started from here, like after y, but we are starting from x. So we'll put a minus sign. So what we are going to do is a1 c2 minus a2 c1. a1 c2 minus a2 c1. So this is y term, right? And then there is a constant, which we are going to now do the calculation for. Again, we have 3 x, y, and constant. So for the constant, we are going to use this and this. Okay. So it becomes a1 b2 minus a2 b1. So using this equation, so once you have this type of equation ready, uh, you can apply this to get the values of x and y. So any one of these is available, we can find out the others here, right? So we are going to see the questions, how we are going to solve it in the next upcoming slides as well. But then let's do an example here. Let's say we have 2x plus 3y minus 4 equals to 0, or plus 4 equals to 0. And we have x plus 4y minus 5 equals to 0. Okay, or let's say plus only so that it becomes easy for the calculation for now. So this is the question that we are going to do. So for x, what we are going to do, we are going to use v1 and c2. So for x, as you see here, we are going to use y and constant terms only. Okay, so it becomes 3 5 is 15 minus y second term and the constant first term. So 4 into 4 is 16 equals to y upon. So for y, what we are going to do, we are going to use this x with this constant and this x with this constant. But then we are going to put a negative sign as well. So here in our scenario, it becomes 2 5s are 10 minus 1 into 4 equals to 1 upon. Again, for the constant term, we are going to use x and y coefficients. And then we are going to multiply this a1 with b2 minus a2 b1. So now our scenario it is 2 4s are 8 minus 1 into 3 is 3. So therefore it becomes x upon minus 1 equals to minus y upon 6 equals to 1 upon 5. Therefore, x becomes minus 1 upon 5. So this is the value of x that we have found out. And y becomes minus 6 upon 5. So that is minus 1 whole and 1 by 5. right? So this is how we are going to solve the equations of this type. Okay, so let's go to next question that we have here. So we have two equations again here, mx minus ny equals to m square plus n square and x plus y equals to 2m. So we have to find the value of x and y here to solve this equation. Okay, so what we are going to do is, uh, let me just write down these equations in the same form which we can apply the previous learned method. So it's mx minus ny is just as it is. Mx square plus n square, moved it to the same side as mx minus ny, and I have put a negative sign because whenever you move things from one side off equals to another, the sign changes. So that's why I put a minus sign here. Then the second equation is x plus y, again minus because it is moving to the left hand side, minus 2m equals to 0. Right? Now, for x, what we are going to do, we are going to use, not using the coefficients of x, but using the coefficients of y and constants. So, b1 upon b1 into c1 minus b2 c2, right? So, b1 is minus n into minus 2m, that becomes 2nm. Uh, then this 1 into minus m square plus n square becomes plus m square plus n square equals to y upon or minus y upon. So again, we are not going to use the coefficients of y, we are going to use the coefficients of x and the constant terms, right? So it becomes a1 into c1, a1 into c2 minus a2 c1, right? So it becomes m into minus 2m, that becomes minus 2m square, and 1 into minus m square plus n square, that becomes minus m square plus n square, but then I have to put minus, so it becomes plus m square plus n square equals to 1 upon. So now we are not going to use the coefficients of constant terms, but we are going to use the coefficients of x and y only. So here we're going to use a1 b2 minus a2 b1, right? So m into 1 becomes m, and 1 into minus n becomes minus n, but then since we are going to put minus again here in front, it becomes plus n. Okay, so if you see closely here, so m square plus n square plus 2nm, it becomes m plus n whole square equals to minus y upon m square plus n square minus 2m square. So this gets cancelled, right? It becomes n square minus n square minus m square, but then okay, let me write it down like this only, because these two terms gets handled together, right? When they will subtract from each other, that's why it becomes n square minus m square equals to 1 upon m plus n. Now, if you see x, if I move this m square, m plus n whole square to the top, if I use this term and this term, it becomes m plus n whole square upon m plus n, right? So, this is the same term that is written on the top. So I can remove one term and remove the denominator as well. So therefore, x is m plus n. Hope this is clear. Okay. Similarly, for y, what I'm going to do is I'm going to multiply this minus below. So it becomes m square minus n square. Uh, that equation changes its sign because I'm going to multiply minus both numerator and denominator. So that's why it becomes m square minus n square. And I have brought it. So I'm going to use this and this. So m square plus m square minus n square is brought to the top. And in denominator, we have the same thing, m plus n. So if you know m square minus n square formula, it becomes, so a square minus b square is, can you tell me what is the formula of a square minus b square? It is a minus b into a plus b. So this is the same formula that you have learned before, and we are going to apply this formula here. So m square minus n square becomes m minus n into m plus n. And in the denominator, we already have m plus n. So if you see, these two terms are same. So I'm going to cancel them. So therefore, y becomes m minus n. So we have found the value of x as well and found the value of y as well. So that was a question, right? I hope you understood. So these formulas that you have learned before, you have to revise them so that you can apply them wherever required. So we'll create a separate video where we'll tell the formulas, different formulas that you have learned already, and you are going to use it in your 10th as well. So we'll create a separate video for that. So for now, I'll go to next video, next question. Okay. So we have here a square upon x minus b square upon y equals to 0, and a square b upon x plus b square a upon y equals to a plus b, where x and y are not equal to 0. So we have to find out the values of x and y here as well. All of these questions that we are doing or that are present in the videos that are on this channel, all of them have come in the different board exams. So these are very important for you to understand. Okay. So what I'm going to do here is, see, I know when x is in the numerator, I can solve this question. But now here x is in denominator. It's a bit difficult for me, right? So what I'll do is, I'll say 1 upon x is u and 1 upon y is v. So the equation becomes a square u minus b square v equals to 0, and a square b u plus b square a v equals to, let me do one thing. Let me bring it a plus b to the left hand side only, minus of a plus b equals to 0. So now equation is in the terms of u and v. Once we find u and v, we can find x and x and y also. So the equation has a bit changed that we have to find u and v now first. So here, if you see in the first equation, we don't have a constant term. So let me just do it like this so that there is no confusion for you. Right? Minus 0 equals to 0. Uh, so, okay. So we are going to use the same trick that we have learned just now, the same approach. So here u, when we are using, or maybe let me just put this here below only, plus b square a v minus of a plus b equals to 0. Okay, so I can remove this whole thing. This is not required. Okay, so I'm going to apply the same thing here now, the whatever we have learned. So for u, I'm not going to use the coefficients of u. I'm going to use the coefficients of v and constant term. So u becomes u upon minus b square into a plus b, right? Minus and minus gets cancelled. Minus b square into minus of a plus b. So that gets cancelled. It becomes b square into a plus b. Okay. Minus b square av minus u. Oh, sorry, minus 0. B square a into 0 becomes 0. So I don't need to write anything here in this case. I'll just leave it as is. Okay. I hope this is clear because we are multiplying b square a with 0 because there is no coefficient or no constant term here in the first equation. So this gets uh, cancelled and it becomes 0, right? So that's why I have not put anything in front of this part. So coming to the v part. So again for the v, I'm not going to use the coefficients of v. I'll use the coefficients of u and the constant term. Again, I'll put minus here in the beginning. A square into a plus b. And again, we have minus in the beginning. So I'll put minus as well here. Minus a square into a plus b. And since there's a negative, so the second part is that we are going to multiply a square b with 0. And again, that goes away. We can't do that. So it becomes 0 only. So there is no meaning of putting 0 here in the end. So I'll leave it as is. One more thing that to notice here is this minus also gets cancelled here, right? And for the last part, the constant part, I'm not going to use the constant terms. I'm just going to use the u and the v terms. So here, if you see, it becomes a square into b square. So let me write a square into b square minus of, so minus is already there, minus b square into a square b. So it becomes a square b cube, right? So what I'm going to do is, and I'm really sorry. So this is a square into b square a, not b square only. So it becomes a cube b square minus. So this minus is already there. So this will get cancelled and will become positive because minus minus is positive, and it becomes a square b cube, which is nothing but if I put take a square b square common, it becomes a square in a square b square into a plus b. So therefore, we can say u is b square into a plus b upon a square b square into a plus b. So this gets cancelled and this also gets cancelled. So u becomes 1 upon a square, which means since u is 1 upon x, 1 upon x is 1 upon a square, which means x is a square, right? And similarly, for v, we have, so I am going to move this part to the numerator on the right hand side. So it becomes a square into a plus b upon this same term that I'm going to use here, a square b square into a plus b. Again, these things gets cancelled and v becomes 1 upon b square, which means 1 upon y becomes 1 upon b square, and therefore y is b square. So this is one answer that we got for the y, and that is the answer for x. So we have find out x and y both, right? So that's how you solve these questions. And I think this is also clear to you. So if you see this kind of equations, it's a bit difficult solving without substituting the values of, without substituting 1 upon x and 1 upon y. It becomes a bit easy for us to solve these equations in this case. So that's what we have done. And using this trick or the method that we have learned just now, this becomes easier because we directly get the values of the variables. Okay. So I hope it's clear. Let's meet again in the next video. Thank you.